In 1859, a British astronomer named Richard Carrington was looking at the sun through his telescope, sketching dark spots on its surface. Then he saw something that made him freeze. A massive white flash erupted from the sun, so bright he could see it even through the dark filters protecting his eyes. He didn't know it yet, but he'd just become the first person in history to witness what we now call a solar flare. He wrote it down, told some fellow scientists, and probably went about his day. 17 hours later, the sky went crazy. All across the world, people saw the northern lights as far south as the Caribbean. People in Florida and Cuba watched the sky dance with colors they'd never seen before. Telegraph machines, basically the internet of the 1800s, started sparking and catching fire. Operators got electric shocks. Some systems kept working even after being unplugged. This became known as the Carrington Event, the biggest solar storm ever recorded. Scientists say that if the Carrington Event happened today, it would knock out power grids, destroy satellites, and send us back to the Stone Age. Not for days, for months, maybe years. But here's the really wild part. What Carrington saw that day wasn't the whole story. He thought he had looked at the sun, but he was only looking at the surface while missing the invisible chaos happening above it. Layers of superheated gas, magnetic explosions, and energy releases that dwarf anything we can imagine. Basically, we think we know the sun, but when you look at the sun, the light hitting your eyes actually left 8 minutes ago. So as time passes, scientists are discovering the sun is way stranger and way more dangerous than we ever imagined. Let's get into it. When you look at the sun through special filters, it looks like a smooth, glowing ball. Calm, peaceful. But that's a trick. What we're seeing is the surface, the place where light finally escapes after being trapped inside for thousands of years. Now here's where it gets weird. Right above this surface, something happens that breaks all the rules. The temperature goes up. Think about a campfire. The closer you are, the hotter it feels. Walk away and it gets cooler. That's just how heat works, right? But the sun doesn't follow this rule. Just 1,200 miles above the surface, the temperature suddenly jumps from about 10,000 degrees Fahrenheit to over 2 million degrees Fahrenheit. The outer atmosphere is nearly 200 times hotter than the surface below it. Pretty weird, right? Imagine if the air 5 feet away from your fireplace was somehow hotter than the fire itself. This mystery taught us something, though. We've been looking at the sun all wrong. The real action, the explosions, the chaos, the dangerous stuff, it's completely invisible to our eyes. That's why when scientists started using special cameras that can see types of light our eyes can't detect, they saw something incredible. The sun's outer atmosphere simply isn't peaceful at all. It's a war zone. Solar flares are millions of nuclear bombs going off at once. They happen when the sun's magnetic fields get twisted up like rubber bands and suddenly snap. The radiation from these explosions reaches Earth in just 8 minutes. There are also coronal holes, dark patches where charged particles blast outward at over 1 million miles per hour. When this solar wind hits Earth, it crashes into our planet's magnetic shield and gets funneled toward the poles. That's what creates the northern lights. Then there are these massive loops of glowing gas that arch out from the sun's surface. Some are bigger than the distance from Earth to the moon. When they collapse, the gas rains back down. Each drop is the size of an entire country, raining fire onto a surface that's already made of fire. But the most dangerous thing remains something called a coronal mass ejection, or CME. To explain what CME is, imagine the sun burping out 1 billion tons of magnetized gas in one giant blob. That blob speeds through space at thousands of miles per second, and when it's aimed at Earth, it can arrive in less than a day, and when it hits us, things get really, really bad. The 1859 storm was a warning shot by all means, but another instance happened in 1989. On March 13, 1989, a solar storm hit Earth. Within 90 seconds, the entire province of Quebec, which is twice the size of Texas, went completely dark. 6 million people suddenly had no power in the middle of winter, no heat, no lights. People were trapped in elevators and subway systems. Dr. David Boatler, who studies space weather, calls it the biggest geomagnetic storm of the space age. And that was a small storm compared to what the sun can actually do. If you're okay hearing something terrifying, listen to this. Later in July 2012, the sun further let loose with one of the most powerful storms ever recorded. It was at least as strong as the Carrington Event, maybe stronger, but it missed us. By 9 days, which means if Earth had been in a slightly different spot in its orbit, just 1 week earlier, it would have hit us dead on. Scientist Daniel Baker said, if it had hit, we would still be picking up the pieces. Other scientists estimate that a storm like that would cause between $600 billion and $2.6 trillion in damage just in the United States. And to help you understand it, let me paint you a picture of what would happen. First, all our satellites would start dying. GPS stops working, planes can't navigate, your phone's weather app goes blank. Then the power grids start failing. The storm would create massive electrical currents in the ground, and those currents would overload the system. Transformers would overheat and literally melt. Now here's the scary part. Those transformers can take months or even years to build and replace, and the factories that make them would also be without power, which means some areas might be in the dark for weeks, others for months. We'd have 8 minutes of warning between when we see the solar flare and when the first wave of radiation hits. Then 15 hours to 2 days later, the main storm arrives. This isn't science fiction. It's just physics. And it's not if it will happen. It's when. The sun goes through an 11-year cycle, sometimes quiet, sometimes active. Right now, it's getting more active. The sun is waking up. So to really understand the sun, scientists look at it using different types of light that our eyes can't see. And each type shows them gas at different temperatures. For instance, one view might show a solar flare as a bright flash. Switch to a different type of light, and suddenly it's a massive loop of hot gas. Switch again, and you see a shock wave rippling out from it. It's all happening at once, layered on top of each other. That's why if you zoom in on the sun's surface, it's not smooth at all. It looks like boiling water, except each bubble is bigger than Texas and only lasts about 15 minutes. Scattered across this surface are dark spots called sunspots. They're where the sun's magnetic field is strongest, and they're where solar flares and CMEs are born. More sunspots means more explosions, more danger. Below the surface, we can see there's also an ocean of hot gas stretching down thousands of miles. At the very center is the core, where nuclear reactions power the sun. It's about 27 million degrees down there, but we've never actually seen any of this. Light created in the core bounces around for tens of thousands of years before it finally escapes. So when you feel the sun's warmth, that energy began its journey before recorded history. The sun is literally shining ancient light on us. All that said, there's one special moment when ordinary people can see the sun's outer atmosphere without fancy telescopes, total solar eclipses. When the moon passes directly in front of the sun and blocks it completely, the blinding glare disappears. For a few minutes, you can see this ghostly halo of light extending into space. That's the corona. Ancient people saw this and thought the world was ending. Modern scientists practically lose their minds with excitement. The next big eclipse crossing North America is expected to happen in August 2026. If you're in the right spot, you'll see the sun as it really is. Not just a bright circle in the sky, but a star surrounded by a crown of fire and magnetic chaos. The sun is 93 million miles away. We've been studying it for centuries, and yet we still can't answer basic questions. For example, why is the outer atmosphere hotter than the surface? Nobody knows for sure. Can we predict when the next big solar storm will hit? Not really. We can see when one happens, but we can't tell you it's coming more than a day or two in advance. However, scientists are making progress. They're not just doing this for fun. They're doing it to protect us, to give us warning before the next big storm hits. Because here's what we know for certain. Another Carrington event is coming. Maybe in our lifetime, maybe in our kids' lifetime. But it's coming. The 2012 storm missed us by 1 week. 1 week. That's how close we came to a disaster that could have changed modern civilization. Next time, we might not be so lucky. The scientists studying the sun are like storm watchers, trying to give us a heads up before the big one hits. And when it does hit, because it will, we need to be ready. If you want to explore more mysteries of our universe, from the violent beauty of stars to the strange physics that shapes everything around us, subscribe and join us as we uncover the forces that make our world work.